Hello friends, in this video we will discuss about spherical capacitor charge cell. First, what is a capacitance? What do you mean by capacity? And what is the concept of capacity? Then capacitance of spherical conductor, then setting of charge in a spherical conductor, and these are the fundamentals of capacitance. Okay, now let us come to the concept of capacitance. What is a capacitance? Capacitance means it is the ability of a conductor to store charge. Okay, ability or internal strength of a conductor to store charge. Now this is called ability. Now experimentally it can be shown that charge given to a conductor increases, raises its potential. If Q is the charge, V is the potential, rising potential due to the absorbing of the charge Q, then you can write Q equal to CV. That is, C is called that intrinsic property of the conductor due to which it is capable of storing charge, and that C is called constant of proportionality, and you can define C is the ratio of charge given to a conductor to the potential induced. Now C neither depends upon Q nor depends upon potential. C depends on only nature of the conductor, geometry of the conductor, and the dielectric medium where the conductor is placed. Okay. Now Q proportional to V, that means greater the Q, greater is the V. Therefore, the ratio of Q by V, it is a constant quantity. Now, in terms of work or potential energy, we can convert Q divided by V as work divided by charge. Okay, Vc equal to Q square divided by work. You can convert it like this. So this is your concept of capacity, and any conductor capable of storing charge is in general called capacitor. But the construction of a capacitor is general some other things. A charged plate is placed near an earthed plate. Then it is based upon the principle of electrostatic induction. So this type of arrangement is usually called capacitor, but any conductor is capable of storing some charge. So this is the principle. Okay. Now let us first come to the capacitance of a spherical conductor. Now just to consider, a conductor is bent into the form of a sphere having a radius r, and you provide charge Q to the conductor, and the charge distributes uniformly over its surface. Therefore, the lines of forces near the surface indicates that all the lines of forces, they diverge from the center, that is called the center of charge or center of the sphere. Okay, if charge Q is given, then on the surface, what is the potential? Potential on surface, that is on surface. What is potential? V equal to K Q divided by R. K is 1 by 4 pi epsilon 0 Q divided by R. So this is your potential. Therefore, what is capacitance? As per the definition, Q divided by V, that means 4 pi epsilon 0 into R. If you assume the medium is air or vacuum, the medium is air or vacuum. Now, if the medium is completely filled with dielectric of constant K, then you put capacitance in medium, that is 4 pi epsilon R, that means 4 pi epsilon 0 dielectric constant into R. Now this shows that Cn divided by C is K. K is dielectric constant or relative permittivity. Thus, a permittivity, relative permittivity or specific inductive capacity or dielectric constant is defined as the ratio of a capacitor in a medium, in that medium, to the capacitor in air or vacuum. Now, Cm divided by C, therefore this is ratio of the two identical terms, therefore dielectric constant is unitless and dimensionless constant. Now, if you connect this capacitor to earth, suppose if you connect to earth, then electrons from earth, it flows to the conductor and it neutralizes. Therefore, in that case, there is on earthing mark, on earthing, V becomes 0. Therefore, C is Q divided by V, that will be tends to infinity. That means capacitance of capacitor becomes infinity, which is practically not possible. On the other hand, if you want to produce 1 farad capacitance, 1 farad capacitance in air or vacuum, then 1 farad, that equal to 4 pi epsilon means 1 by 9 into 10 to the power 9 into R. So from that, R is 9 into 10 to the power 9 meter, that equal to 9 into 10 to the power 6 kilometer. That means in order to produce only 1 farad, which is a SI unit of capacitance, 1 farad capacitance, now the radius of the spherical capacitor should be equal to, in the order of 10 to the power 7 kilometer, means 9 into 10 to the power 6, order is 10 to the power 7 kilometer, which is practically not possible. That means this type of a capacitor is practically not usable. Okay. Now let us come to the third property, shedding of charge in a spherical conductors. Shedding of charge in a spherical conductors means, just to consider, this is a conductor, spherical, should say radii is R1, this is radii is R2. Okay. Now charge Q1 is given to the first conductor, similarly Q2 to second conductor, potential developed here is V1, here is V2. Now this is capacitance is C1 and capacitance is C2. So initially both the two capacitors are isolated. That means they are far away from the system. Therefore, the total charge of the system, Q equal to, right, Q1 plus Q2. If you assume both the two conductors possesses charge Q1 and Q2 and they constitutes one system, then the total charge Q equal to Q1 plus Q2. Okay. Now Q1 is, this is C1 V1, this is C2 V2. On the other hand, in terms of capacitance and potential, then you do one thing, both the two charges, that is they are connected by means of a conductor. If they connect by means of a conductor, then charge flows from one conductor to another conductor if potential of one is larger than that of the potential of the other. That means if there is potential difference is not equal to 0, then condition charge flows. Suppose if I take V1 is greater than V2, then charge flows from first spherical conductor to second spherical conductor. Now, after a fraction of a second, the charge of Q1 becomes net Q1 prime, charge of Q2 becomes Q2 prime because Q1 loses and Q2 gains. Okay? Now, that is accordingly, if they are joints by means of a conductor, both represents a single system. If they represents a single system, that is a plus and a plus are connected, you can say it is a parallel combination. Then in that case, that is the potential becomes the same, and that potential is generally called common potential. Okay, common potential. So what is the value of common potential? Common potential is total charge divided by equivalent capacitance. Equivalent capacitance, total charge is Q1 plus Q2 divided by, that is C1 plus C2. Equivalent capacitance is C1 plus C2. On the other hand, in terms of capacitance and potential, this is C1 V1 plus C2 V2 divided by C1 plus C2. This is the potential common. Okay. Now, since Q1 prime, on the other hand, you write Q1 prime equal to C1 by V, Q2 prime equal to C2 by V. Therefore, this shows that Q prime proportional to C and Q1 prime divided by Q2 prime, that equal to C1 by C2, and this is R1 by R2. Now, this is after connection. After connection, this is the important mark. Both the potential remains the same. Therefore, charge and capacitance arrange. Greater the charge, greater the capacitance, greater is this charge. So that Q1 prime by Q2 prime equal to C1 B C2 B. V cancels. Further, C is 4 pi epsilon 0 R. Therefore, C1 by C2 is equal to R1 divided by R2. Okay, C1 by C2 equal to R1 by R2. Therefore, in that formula, you write this is R1 V1 plus R2 V2 divided by R1 plus R2. Mind, what is R? R is radius. It is not resistance. It is a radius of the spherical conductor. Okay. Now, that is from this, if you want to calculate specifically what is a Q1 prime, okay, so now Q1 prime on the other hand, you can calculate Q1 plus Q2 divided by C1 plus C2 into C1. Suppose in the problem potential is not given, common potential is not given, and it is not asking also. If Q1 is given and Q2 is given, then how can you calculate the charge of individual capacitors if initial charges are given and capacities are given? In that case, you write Q1 prime equal to total charge divided by equivalent capacitance into capacitance of the first one. Similarly, Q2 prime, that is Q1 plus Q2 divided by C1 plus C2 into C2. This is generally called this value, that is common potential into C2, common potential into C1, and this is common potential into C2. Or you write this as a, that is Q1 plus Q2 divided by R1 plus R2 into R1. Similarly, Q1 plus Q2 divided by R1 plus R2 into R2. in terms of R1 and R2 also you can calculate, it is possible. Okay, and these are the things only if you use spherical conductors as a capacitance. Okay, now here that is before connection you can find out what is energy. Energy, what you call the initial, this is a half C V square, this is a half C V square, this is a half C1 V1 square plus a half C2 V2 square. Now after connection, this is energy final half C1 plus C2 into common potential square, C1 plus C2 into common potential square. Now when the system loses energy, when the system loses energy, a loss of energy is converted into heat or sparking. Sparking means it is a light and partly light and sound. Therefore EF minus EI, if you put the values and solve it, then you can find out half C1 C2 divided by C1 plus C2 into V1 minus V2 whole square. So this is the loss of energy. You can put a minus sign. Okay. Now if you like this video, like it and subscribe it. Thank you.